Okay, so welcome back for video number 2 on volumes. Remember from last time, if we have a cross-sectional area, A, we can compute the volume by finding this integral, A of x dx. Okay, so what about, so last section, in section 6.1, we would have situations like this, where, well, let's look at y equals x, y equals square root of x. This intersects at x equals 0 and x equals 1. And if we want to find the area bounded, we get this thing. What about if we wanted to revolve this around the x-axis? We can, but it will be a little bit different, right? It will look like a solid, but that solid has this inside area that is going to be hollow, right? Because you're revolving this top part, you get something that goes around this way, and then the bottom part, something goes around this way, and that inside is going to be filled, or the middle is going to be filled, but the inside is empty. So we get something hollow. Now, I already drew the cross-section. Cross-section looks something like this. In math, we will, some people like to call this a donut, but in math, we often call this an annulus or a washer. From the center, you have your first radius, little r, and then you have your second radius, big R. And the area of this thing is going to be pi r squared minus pi little r squared, or pi r squared minus little r squared. And that just comes from, well, pi r squared would be this big disk, including the little bit that we don't want. So we want to subtract out this little bit that we don't want to get what the area is that we're looking for. Well, we could do a similar thing looking at the specific case that we have that we did last time. So here's our washer. Here's going to be where the x-axis is. This first radius going up this way, well, that's just going to be our bottom function, right? Y equals x. Because if you do y equals x, you'll get this point right here. And what about our second longer radius? Well, that's y equals square root of x. So this works out nicely that it's going to be our larger radius squared minus our smaller radius squared, where those radius are just our functions. So it's going to be the top function squared minus the bottom function squared. Now this method, so last time we were doing the disk method. This method is called the washer method because our cross-sectional area is using washers. And from here, we can go back to that integral and compute this. And we would say this is by the washer method. So it's from 0 to 1 of pi, and then this is going to be x minus x squared dx. Just coming from the fact that square root of x squared is just x. So we can compute this thing. Pi 0 to 1 x dx minus pi 0 to 1 x squared dx, or pi over 2x squared 0 to 1 minus pi over 3 x cubed from 0 to 1. We can compute this thing to get that this is pi over 2 minus pi over 3, or pi over 6. Okay, so then pi over 6 would be this volume, and we did it by Washer method, which is the method that I would like to focus on today. So let's just do 2 more examples. First example, find the volume by revolving around the x-axis of the area bounded between these two curves. Okay, so we can find where they intersect, because we don't have that. Where do they intersect? Well, subtract over, factor, and so x equals 0 or x squared equals 1. And on this particular problem, I'm going to take x to be positive, greater than or equal to 0. So that means x is 1. Okay, so this volume here is going to be 0 to 1. Okay. So, what next? Well, we have to find a. A is going to be pi, and then the big function squared minus little function squared. So we could graph this on 0, 1, you have x, and then you have x cubed. So x cubed goes on the bottom. So because of that, this will be pi x squared minus pi cubed squared, or pi x squared minus pi x to the 6th. So that's what we're going to be integrating. So our volume is 0 to 1 pi x squared minus pi x to the 6th dx. You could separate these integrals again. And pi is a constant, so it pulls out of the integral. So this is pi over 3x cubed from 0 to 1 minus pi over 7 x to the 7th from 0 to 1, or pi over 3 minus pi over 7. And what does that give us as a final answer? Well, this is going to be 7 pi over 21 minus 3 pi over 21, or 4 pi over 21. Which gives us our volume. Okay, so let's do one last example. Just looking at, instead of revolving with respect to x, we're going to revolve with respect to y. So let's take this situation. X equals y squared. X equals 2y about the y-axis. So we can see where they intersect by setting them equal to each other. And solving, so we factor out a y, you get y minus 2 equals 0, which means we have that y equals 0 or y equals 2. That gives us bounds for integration. Now we have to think which function is the quote-unquote on top function. Now remember from last section I said what might help you is to see which one's on top and which one's on bottom is switch the x and the y. Between 0 and 2 is y equals x squared on top, or y equals 2x. Well, you can graph this. So first function, you have 2, 4, and it's the line connecting them. Or that's the second function. And the first function, and let me draw this a little bit better. That was worse. Apologize. So this is where the other function would lie. So looking at it, it looks like our little one is going to be this one, and our big one is going to be y equals 2x. So that translates up here into this one's our little one, and this one's our big one. Now, if you choose the wrong one, just know that your integral will be negative, a negative volume. That will be the only difference there. So if you get a negative, just know that you probably chose your little or big one incorrectly. So what is our area? Well, it's going to be pi, big one, quantity squared minus little one, quantity squared. Or pi 4y squared minus y to the 4th. So we can compute this volume now as from 0 to 2 for those bounds of integration we solved for before. And then our A dy, because we're revolving with respect to the y-axis, so we should have a dy. So separating these, this will be 4 pi 0 to 2 y squared dy minus pi 0 to 2 y to the 4th dy. Or 4 pi over 3 y cubed from 0 to 2 minus pi over 5 y to the 5th from 0 to 2. And this is when you start to pull out those calculators, because 2 to the 5th is not something you might be able to do in your head, but that is 32. So let's just do the last little bit of computing this. So the first one, it will be 4 pi over 3 times 2 cubed is 8, and then minus 0, minus pi over 5 times 32 minus 0. So, get 32 pi over 3 minus 32 pi over 5 or 160 pi over 15 minus 96 pi over 15, which gives us a final one of 64 pi over 15. And that is our volume. Okay, so up to this point, we've been talking about revolving around an axis. The last little bit, what I want to talk about tomorrow, is do a couple examples of what if you want to revolve around a line that is not the y-axis. How do we approach that? So I will see you tomorrow for that video.